Feedback from previous years? Well, first feedback is that the students really enjoy it. Enjoy it in the sense of serious fun. I mean, it's stressful, it's hard, it's challenging, but in the end it's a great deal of fun. Students do not like being assessed by their peers. That comes across loud and clear every year, and I'm sorry, you're going to have to do it. We do what we can, and I'll try and describe that later. We'll do what we can to make sure it's fair and reasonable, and that any undue bias is taken care of. But in the industry, a lot of your work is going to be assessed by your peers, and you'll have to learn both how to give a good review and how to take a good review. So this is incorporated into the subject. The early weeks are a challenge, mostly because everybody's rattling around and not knowing quite what to do, and the team hasn't fully formed and people are not organised. So it's something of a challenge. We do what we can to help you out with that challenge and get you working as best we can. But the emphasis is on you must learn how to work your team. We can't sit around telling you what to do every day. The second half usually goes a lot smoother because by now you've been through enough that you know what you're doing, you know what's expected, and you just get on and do it, and it's pretty slick. Now let's talk about how the subject is run for a little while. The way it's run is that each team meets with their tutor each week. They do that to review the project schedule, to ask questions, answer questions, and it very much is a status meeting, a tutorial meeting where you can ask the tutor for some advice, you can clarify things, and it's the one time the group gets together. Now I will insist that the groups do get together each week, and this particular semester is really good because we've got classrooms where all groups have a workstation with a monitor. You can plug in and everybody can see what's going on, and it's a really good setup. So I do expect all groups to turn up each week and to run at least one meeting each week in that room. What you should do? Well, just like any stand-up meeting, any agile stand-up meeting, you need to review what has been done and what hasn't been done, what you already know and what you don't know, and that is the things that you know you don't know and need to learn. So that's all part of the work you need to do. You need to review what problems you currently face. You need to sort out what needs to be done and who's going to do it. And you'll need to also try and understand whether the whole thing is working well or not. Changes this year? Invariably I change the subject each year because there's a couple of reasons for that. This year I've changed the marking scheme, as I seem to do each year, in some attempt to reduce the number of high distinctions. This subject has I suppose an enviable or an unenviable record of producing a large number of high distinctions, and that in itself is not a problem. But what the problem is that when I look at the work, I don't think that work is of high distinction. It's good work, but my task is to try and devise a marking scheme where work that achieves high distinction really is work of high distinction. So we're trying again this year. There is a new case study. Right now, I don't have it in front of me. I'm expecting ITD to present it to me really soon. And if they can't really soon, then I'll just have to make one up. But it will be new. It will be different from previous years. As I said before, in previous years there was a presentation to the customer. This year is not, and this year it's just a peer review. So you're still presenting your work, but it's as a group to another group, your colleagues, and they their role is to listen and to advise, and you get to swap around. What are you expected to do? Well, you've been assigned to a group randomly. This is very deliberate. Part of the reason is to spread the expertise about. There are the IT students, there are engineering students, as a collection of people through the cohort. And it's unreasonable to get a bunch of hotshots together. That's not on. Let's spread the expertise about a bit. Second reason for doing that is that this subject actually, it has a prize that goes with it, and it's cash prize. I've forgotten exactly how much it is. I think it's $600. It's not a lot, but it's a cash prize, and people try to compete for it. Now, anytime that happens, everybody has to have a reasonable chance, and so the way to assure a reasonable chance is that everybody is assigned randomly to a group. That's what we'll do. Your job, your first job, is to turn a group of individuals into a functioning team. Then decide how the team will behave and who will do what. Got that? Then turn up the wick, turn on the afterburner. The role of the staff, you will have a tutor, and their role is to help and advise. Not to do it for you and not to tell you what to do, to help you to do it and to advise you on doing it. The tutor will step in if they think you're going to make a mess of it. It's rare, but it happens. I've done it, and other tutors have come and talked to me about a group and said, well, I think we need to intervene. And so we will. But if you're insisting on making a mess of it, we'll let you do it. The tutor will mark your deliverables. So there are 4 deliverables in the first half of the semester. There are 3 basic documentation type deliverables plus the system to deliver in the second half of the semester, and your tutor will mark those. There is a marking scheme, and that goes some way to ensuring that the marks are fairly evenly done. Your tutor. Now, this subject has a reputation for being expensive because we insist on employing as many industry-based people as we can to be tutors. Any other tutors, student tutors for example, must have experience of developing software. All right? It is very essential in this subject that your tutors do know what they're talking about. They do know software engineering. They do know what's going on in the industry, and they can advise you. What works and why does it work? Well, what I found is that real problems with real clients work better than theoretical academic exercises. They're not that much difference in their substance, but it seems to make a difference when people can relate it to an actual real problem. So I strive to get a real problem with a real customer that can be done. The problem is small enough that you can do it, but big enough to be challenging. A lot of people look at the problem initially and think, I could knock that off in a couple of weekends of programming. Well, you probably could, until you start doing it. Believe me, I have had a number of times when there's been a coding hotshot in the group, and the group has decided to leave all the coding to them. So right, we'll just produce that. And 2 things happened. One, they didn't learn much. And the second thing is the hotshot code cutter didn't get it finished. It's deceptive. It takes a great deal more to do than you think. So leaving it all to one hotshot isn't going to work. This is discovery-based learning. It's not lecture-based learning. It is discovery-based learning. I have provided a set of lectures. They're mostly introduction type things to introduce you to the subject and to point out the kinds of things you could do. They are not definitive lectures about here's how you do something. They can't be. Aside from which, the knowledge about how to do things at this level is fairly readily available. You just go Google it. It's easy. Everyone tackles the same problem. Now that has been true in years past. It's true this year. It may not be true in future years because we may combine the subject and may have to give a selection of problems to suit different degrees. For example, the IT type students, commercial type students will probably do a commercial type problem. Engineering type students are more likely to do a engineering, say a control system type problem than a commercial system. There is competition between the teams, and you guys get really competitive, so that works pretty well. And there is peer learning between teams. There is nothing to stop you talking to your peers and saying, how did you do this? What did you decide that? This is encouraged. What's not encouraged is copying their work. That's just not allowed. Forming teams. Over the years, we have observed that a functioning team works a great deal better than simply a collection of individuals. We have seen both. So the faster you can get to a functioning team, there's a fully engaged team where everybody knows what everybody else knows, everybody knows what they're doing and what everyone else is doing, and the whole thing is what in the industry is called a gelled team, and it rocks. That's really good. Now, the faster you shift from a group of individual people into a functioning team, the better. We figure it's going to take about 3 weeks to get up to a reasonable speed. To do that, largely in the first lecture, there'll be a certain amount of talk about the subject, and then you'll be directed as a team to just walk around the team, go around the team, say, right, who are you? What are your goals? What knowledge and skills do you bring to the party? What is it you want to do? That is, what mark do you want to get? And what do you want the system to be? Do you want to make the slickest system that anybody ever seen, or you want to get a high distinction, or are you just happy with the past and happy with any system that actually works? It's all allowed, and you just do whatever it is you want. I have a wee survey. It's a 4-question survey, and I've run it a few times. It does seem to give some indication of whether the team is actually functioning well or not. But it's not a compulsory part of the subject. It doesn't go toward assessment, and so I can't impose it on you. I can't encourage you to do it.